I don't do anything new. Okay, so this is 1 hour per week of your time, meaning we do what things you need and want me to do. So, for example, if there were questions from this week that you thought, oh, that's a little bit hard, I can't do it, I'd like to see it done, then I can do it. If there's questions you want more examples of, I can do it. If you just want to practice some questions yourself and then have me check it, I can do that. So this really is your time. Okay, this is your time. So we'll start by seeing if there's any questions that you had trouble with and you would like me to do. So why don't you check your notes from the last week and tell me what you'd like me to do. Okay, so where are we starting? Don't be shy. Are you shy? Nobody wants to ask me? Or you're really, really smart? The second, yeah? Oh, sorry, the first. Yeah, go ahead.
When we don't need the answer, I can really write blah.
Okay, maybe not blah. You can do ...
It really depends. Even
if that part of the work is totally unnecessary, then yeah. If it's unnecessary, yeah. Okay, so that wasn't really a math question then. Anything else? Don't take this the wrong way, but I can't believe you're all geniuses. So somebody must have a question.
Oh yeah, I want to check my answer, but there's no answer for 4, 5, 6.
No problem.
Quadratic and cubic equation.
Was it making the graph?
Yeah.
Super. Let's do that then. You can compare and check your answer then. So which lesson is that for people who want to open it? A lesson on solve and sketch quadratics, is it? Yeah. And 4, 5 and 6, yeah? Okay. So can you all open the solve and sketch quadratic lesson? Yeah, solve and sketch quadratic. So we'll draw some of these on the board so you can check your answer then. Let me open up my graphing program. So where is long? Does anybody know? No? No? Okay. And nobody in this class has a graphing calculator? No, okay. Alright. It's too expensive. Yep, it's true.
991?
No. This one's only like, what, 20?
$20.
Yeah. No, the graphing calculators for making the graphs. Yeah. Okay, what one did I ask you to do in number 4? AB. Okay, so y equals x squared plus 10x plus 9. Let's draw that. And I'll zoom out. Okay, so it looks like the minimum is at -5, -16 on your graph, and you should have roots that are about -9 and -1 then. Did you get that? Yeah? Okay. What's the next graph? Can you read it to me? Y equals...
squared plus 16x plus 54.
Ah, so this this is x plus 8 squared, isn't it? So this, I think this one only has one root, is it? Yeah, it only has one root at minus 8, which is also the turning point. Did you get a graph like this? Yeah. Okay. What's the next one then in 5? Minus 570. Okay. This is going to be a big one. Oh, no, that's not too bad. Let me... Okay, so it looks like it has a maximum at about minus 7, minus 8, minus 6, is it? Yeah. Okay, so this one's quite narrow here. Because it crosses the y-axis at minus 570, yeah? Yeah. Good, bad? So. Okay, what's the next one then? Y equals... Yeah, so no roots here. No roots for this one. 5b, no roots. Minimum at... what's that, about minus 8? Yeah. Okay. Do you get something like this? No roots for this one. Okay, what are we on now? Oh, that's it for the graphs. Well, oh, okay, and we'll do the proofs then, because you said you wanted 6 as well, wasn't it? 6W. We'll do that one now, yeah? Okay. Y equals x squared plus 18x plus 145. That's equal to x plus 9 squared, and then I have 145 minus 81. What's that, 64, isn't it? So, plus 64. This is always bigger than or equal to 0, and this is always bigger than 0. So therefore, when you add them together, it's bigger than 0. So, always positive. Oh, I'm doing the wrong thing. This is just, it's just another graph question. Okay. Well, doing this, I know what type of graph I'll get as well, because it has no roots, it's always positive. So I'm expecting something above the axis here. Y equals x squared plus 18x plus 145. Yeah, doesn't come close to the x-axis, cross the y-axis at 150. Minimum at minus 9. Actually, I can see the minimum here. Minus 964 is the minimum here. Yeah. I hope your graphs were close to this at least. Yeah. Okay, so what do you want to see next then?
You show me that guy.
Ah?
That fourth
Of course, my favorite method.
I don't understand that.
Yeah, no problem. Gaussian elimination, yeah. Which one did I ask you to do for homework? A, probably. Yeah. This is your favorite question? I don't think anybody is. Right? Yeah. Let's have a look at it. So this is 4a on the degree 2 systems. So we have 2 over 7x minus 3 over 5y equals minus 5 over 9. 2 over 9x minus a half y equals 5 over 7. Okay, block time. 2 over 7 minus 3 over 5 minus 5 over 9. 2 over 9 minus 1 over 2, 5 over 7. Yeah. Right. What to do first? Who's got a bright idea here? Any ideas? Yeah. So what to do that? Yeah. Multiply by. Yeah. I think if we go with 7 and 9, that's a good start, because it gets rid of the 7 here, and it gets rid of the 9, and it makes this a 2 and a 2. But I think I'll go one step further. I'll also multiply at the same time by 10. So in other words, I'll multiply the first by 70 and the second by 90. Because if I multiply the top row and the second row by 10 as well, I'll get rid of the 5 and the 2. So in other words, I can get rid of all the fractions on the left, and at the same time I make the 2's appear here and here. But then if you think about it, if I make the 2's appear, it's a little bit easier if they're 1's, you know, but we'll deal with that later anyways. Okay, so let's multiply by 70. So 2 over 7 by 70 is 20. And then this is minus 21. Minus 3. Minus, no, of course not. Minus 42. No. How about we stop guessing and use a calculator? Minus 3/5 times 70. Minus 42. Are you sure?
Yes, 14.
Oh yeah, okay. No, yeah, I agree with you now. Okay. Minus 5/9 times 70. I don't even think that will work out nicely. Minus 350 over 9. Okay. And now this will be 20. This will be minus 45. And then, oh, this isn't going to work either. I mean, it's going to be messy. What is it? 450 over 7. Okay. So now what to do? Well, I don't want the 20 here, do I? No. So we'll do row 1 minus row 2, and the answer will go on row 2. Yeah. So now let's see what we get. This is the same. 0 minus 42 minus 45 is 3. Oh yes, and we'll need fraction help here. What's that? Minus 350 over 9 minus 450 over 7. Cool. Is there any way to make these the same easily? 3 goes into 42, doesn't it? It goes in 14 times? Oh yeah, because we said earlier. So I'll multiply this by 14. Yeah. So this becomes 42. And then what would this become? Okay, let me just write that down. Minus 13,000. Oh, exactly 13,000 over 9. Great, now, nearly there. What to do next? Row 1 plus row 2 onto 1. Yeah? So now we get 20, 0, and this is the same here. Okay, so I just need to add minus 350. Oh, well, that's obvious. Minus 13350 over 9. Yeah, over 9. Great, so we're nearly finished. We just have to divide this by 20 and this by 40. So this becomes... Oh, thank you. This becomes 1 and this becomes 1. So we finish up with x equals minus 13350 over 180. That possibly simplifies. And y equals minus 13000 360. Now obviously they simplify because you can cancel here and here and here and here. So what do they simplify to? Probably to some fraction still. But and minus 6500 over 189 possibly? For the next one? No, don't say that, because then that means this one's wrong and this one's right, which doesn't make me happy. Minus 325 over 9.
Yeah.
Maybe my answer in the book is wrong. Let's check with the computer program. This is what I'm hoping for, but I don't think this is going to happen. Okay, let me just type in the equation. 2 over 7x minus 3 over 5y equals minus 5 over 9. And then 2 over 9x minus a half y equals 5 over 7. Solve system 2, line 6, line 7. Yeah, that's... So my first one is right, but my second one is not. So it means I made a mistake somewhere on the y.
Divided by 42, not 40.
Ah, so happy now. Okay. So what's 9 times 42, please?
378.
378?
Yep.
Okay, and now if you hit this in, what do you get?
Negative 6500 over 189.
Ah, yeah, which is correct then. Okay. Okay, I'm glad I made the mistake near the end and not near the start. That's quite helpful of me. So it's a difficult method, but it's a difficult method only because you should use it on difficult problems. Because, I don't know, I think when you have fractions like this, it is a bit messy. And then it gets harder when you have more than 2, you know. Okay, so I'm sure some people, if not everybody, had trouble with this. So if you want, you can write it down. If you want, you can try another one. Or we can have a look at another question that was causing people trouble. So what will we do next then?
This matter is not very nice.
Say again?
This matter is not very nice.
This semester is
It's not very nice.
Oh, no, all maths and semesters are my favourite. Yeah, and this method, all methods are my favourite. Yeah. I like this method because it works really well when the problem gets really big and really hard, you know? So like if you had 4 W, X, Y, Z, then it works really well.
Yeah.
I don't think you believe me. You believe me?
I think the question is very bad.
Bad? Bad or hard? Oh, both. Okay, all right. Well, my feelings are it's better if I make the questions harder than the exam instead of easier than the exam. Yeah, these are a bit harder than what you get in the exam.
Really?
Yeah.
Oh, I thought you were asking me to
Confirm. Yes. Yeah. No, I am too. Yeah, you agreed that it's better to have the questions that you practice in class a little harder than what you would have for the exam. It'd be terrible if it was the other way around, where the questions in class were easy and the questions in the exam were hard. Nobody wants this, right? Yeah. Okay, so what will we do next then? So, maybe you can find another bad question we can do. Yeah. The Gaussian one was probably the hardest one we've done so far. Anything else? No? Yeah, but these science students don't care about physics. Do you care about physics? Really? Well, let me put it this way. Do you care about his physics questions?
Our physics program. Yeah.
Oh, it's everyone. What lesson was it?
The block one.
Yeah.
And VAT.
UVATS. Yeah.
Oh.
Okay. Well, I'll do the physics tutorial tomorrow. Okay. What you can do now is you can practice some more questions. Now, there is a website I want to show you, and Mark, you know Mark, the business teacher who was here yesterday. Yeah. He really likes this website, so I think I'll show it in case some of you would like it too. It's called, I don't know if you've ever heard of it, IXL. Do you know this website? IXL? No. Now I think you might have to pay, but it's good for maths and English, and it starts from like kindergarten all the way up to in Ireland this would be the last year of high school here. So if I go here, for example, you can have a list of all the topics. So let's find something we were doing recently, quadratics. And for example here, match the quadratic with the graph. Or solve a quadratic by factorizing. So if you click that, it gives you like a little quiz. You can practice. So here, what's the answer for this one? The two values for k. You can't see? Zero, and second answer? Yeah. And so on. Okay. And then they get harder and harder. So look, if you ever needed to practice something, there's lots of lessons here. I think you have to pay, but they give you so much for free, and then you pay if you wanted to. Another website I want to show you, which you might know. So first just write down this name here, ixl.ie, or no, .com I think, is it? Yeah, ixl.com. IXL. .com. Okay, you got that written down? Has anyone heard of whoops, not this one. This one? You know this one? Yeah, okay. And what do you think of this one? Good, bad? Because I haven't really used it, so you need to tell me.
It depends on who's the one teaching. teaching.
Really? So you have favorites that work well, or?
There are a few that work well, but when they change the tutor, I sort of drift away and sleep.
No, okay. How is it?
So I think it's first one.
Say again?
The constantly, if you're have passion and another passion, they have like physics.
They have physics
And they have physics.
And then calculus.
and calculus. And are they good?
I like it.
Yeah, okay. Alright, good. So that's another website you can use as a resource as well then. Does anyone else have any other websites they want to share with the class for helping others? IXL and CAN are the two I know. Does anyone have any other ones?
I know for physics you can use Crash Course.
Oh, is that on YouTube?
Yeah, it's on YouTube.
Yeah, I think I've seen that one before. I think it's made by PBS or something.
Yeah, PBS.
Maybe this. Yeah, this is a crash course physics. Yeah, so these are they're all like 10-minute videos, aren't they? Yeah.
It's a good summary.
It's a good summary, yeah. So if you need summary of any topics in physics, this is a good little 10-minute video. Does it come with questions? Just the video. Yeah. I like their little animations. I think they're always nice. Yeah. So anyways, if you ever want a little summary video of something we're doing in physics, you can try this one. I think the easiest way to find it is by Googling Crash Course PBS. If you want, can you write that one down as well, please? Anything else? PBS. Public Broadcasting System.
PBS.
Yeah. Huh? What? Anyways, any other websites? I hear he's okay. ED. Oh, yeah. You use this one? I thought it was free. Yeah. Oh.
It's free?
I thought it was free. Yeah, see, free. So, Newton's laws. Yeah, this looks pretty good. Have you used this one? No. Can, yeah. Yeah, no, this looks really good. There's lots of physics classes here you can do. AP is what they call the physics course in America, advanced placement. So AP Physics 1 looks good. It looks like the same level that we do in class. This is, no. Nuclear reactor, no. Quantum mechanics. Introduction to mechanics. Oh, let's see. Yeah, okay. Kinematics. That's what we were doing last time. Cool. Okay, good. So write that one down. Okay. Now, anything else? No. I think that's a good list of websites to be using. This one must be new because it has 0 reviews here. So they must have just started it. Okay, well what we can do now, if you don't have any more questions, you can use this time to practice some more examples from the maths. But physics students, if you want to work on physics, that's fine if you have all your maths finished then, yeah?
I do have a question, but it's more physics.
You have a physics question. Okay, go for it.
Actually, Dr. Lorraine's lecture.
Ah, sure.
Yeah.
Oh, she said, you asked her a physics question and she said, that's Stephen.
Yeah.
Yeah, okay, good. Go for it.
It's about two electrons in only one orbital. Like there's
Yeah.
two maximum electrons in one orbital. I wanted to ask her, but she told me to ask you.
All right. Yeah. Oops. This is like your nucleus, and then you have. Oh yeah, sorry. Yeah. This is like your nucleus, and you have two electrons here, and then on the next orbit you have eight then. And you want to know what's the deal with that? Like why 2, why 8? So I think his name is Pauli, who discovered this. Yeah. Pauli, yeah. I think he's German. No, American, Austrian, Swiss. Okay. So what he discovered was, his rule was basically 2 electrons, to be more precise, 2 electrons can't have, or can't be in the same state. So what we mean by state, these electrons are defined by certain properties that they have. So for example, they have a charge, which you know, they have something called a spin because they're spinning. They have magnetic field. These are stuff that we'll do in physics. And what he said, 2 electrons can't be in the same state. And I'll have to find exactly it here online. But what's happening is, if you had a third electron, then the properties that define this electron will be the same as one of these. I'll give you a very sort of simple day-to-day life example. So for example, in all your countries you have cars with license plates on it. So you can't, what makes your car is what the license plate number is. You know, so the ownership, the definition is the license plate number, a bit like with your passport ID. It's defined by the number. So you obviously can't have 2 cars with the same license plate, because that doesn't work, that doesn't make sense. So it's kind of the same deal with the electron. You have these numbers which define the electron, and what's happening is, in the inner shell, if you had 3 electrons, then 2 of them would have the same license plate. They would have the same numbers. And this is not allowed, because electrons, like the cars, can only be uniquely defined by a set of numbers. What happens is, when the electron moves out into higher orbits, these numbers, they become larger, and you have more range of numbers to choose from. So in the inner shell, I think the only thing that you can choose is what's called the spin number of the electron, which can have a value of plus or minus 1. And this is why it's 2. But then when you move out into the next shell, you have more, it's like your license plate gets bigger, you have more choice of numbers, so then more electrons can sit there. Yeah. So it can actually get a bit complicated, but the simple answer is, the electrons have to be uniquely defined, and they're defined by a list of numbers, and that list is able to be bigger on higher orbits. And the innermost orbit, the only thing that can define electron is called the spin number, which can be a plus or minus 1. But then as you move out, you can add more numbers, like more license plate numbers then. Yeah. If you wanted to look more, look this up more. Let's see if I can find it. I'll try and get the picture. I kind of have a little picture here that might help, I'll show you, but it's not. What did Lorraine tell you anyways? Or she just said, I'm not telling you.
She said that she wasn't familiar, and the last time she learned about this was years ago in university. So she forgot all about it and told me to just ask you.
Okay. Quantum states, as I know what it's called. This might be of some use. How many choices do you have in 2s and 2p? Is it 8? Yeah, and then after that 18? Yeah, okay, this looks like it then. So this is the first one here, and sorry, I said plus or minus 1, I was mistaken, I should have said plus or minus a half. So in the first state, the only available number you have is what's called the spin, and you have two choices here, which is 2. And then if you look at this one, for example, you still have the spin. If we look at 2p, you still have the spin, which has two choices, but now you have this extra thing you can use called a magnetic number, and you have 3 choices here. So if you can choose 2 numbers here, and if you can choose one of 3 numbers here, how many possibilities do you have? You have 6 possibilities in 2p. So if I jump down to 3d, for example, you now have expanded your magnetic number to 1, 2, 3, 4. You have 5 possibilities here. Yeah, and you still have your choice of 2 for spin. So in total for this one you have 10 then, for example. So it's a bit like I was saying the license plate. So in the very first one, the only thing you can choose is spin positive a half or negative a half. So this is why you can't have 3, because it would mean 2 of them would be the same number, which is not allowed then. Yeah. So if you wanted to look up more about this, if you wanted to add this to your chemistry notes, just write this down. The reason for it comes from what's called the Pauli exclusion principle. To write the name down. So the Pauli exclusion principle says that no 2 electrons can have the same numbers, quantum numbers. So simply put, they can't have the same identifying numbers. Because if you think about it, what can identify an electron? Like, how can you tell the difference between one electron and another? Do they both have the same mass? Yeah. Do they both have the same charge? Yeah. They both have the same size? Yeah. So you can't really tell the difference between electrons. There are other things that electrons have which you haven't learnt about. This thing called spin. So electrons can be spinning upwards or spinning downwards. So this is one way to tell the difference between electrons. So the idea is basically, in an atom, in the orbit, the electrons have to be unique. They can't be the same. And since their mass and charge and all of this is the same, then there's only these other numbers that can be different. It's just unfortunate that you don't learn about these numbers because they're quite advanced. They come up like at university chemistry. Unless somebody has learned them before. No. Have you studied chemistry before?
Yeah, at high school, it's also limited.
Yeah, the same thing then. Any other chemistry, physics questions then? Huh? Oh, no, tomorrow.
So you mean, have physics section.
Chemistry / physics.
No.
No, just physics. Okay, well just use these last few minutes just to practice some more questions then. And I think it's a good idea for next week, try to circle the questions in the book you would like to see. So then when we come to class next week, then we can have a good idea what to do. Okay, so just take the last 5 minutes here to practice a couple more. It would be great if everybody could do another Gaussian question. Yeah, it would be great. Thanks. Try, you did all the Gaussian ones? Awesome. Did you try all the Gaussian questions? Go on, give one a try. If I can do it, you can do it too.
Every Thursday is like math tutorial.
Yeah, I think we'll make it every Thursday maths tutorial, and then every Friday will be the physics. One of the hours will be the physics.
Oh, so we have 6 math classes in one week. Because we have another math class tomorrow.
Yeah, is that class with all the students?
I'm not sure.
Yeah, I think we have one class where we're all together tomorrow for a lecture, and then I have the business students by themselves after lunch, so they'll have their tutorial after lunch then. Yeah. Huh? As well? Maybe I have it backwards. Maybe I use the lecture after lunch and the tutorial before lunch. The maths is after lunch for you. Yeah. Okay. Okay. I think this is a lecture, because I think you're all together for that one. You've seen a few of those already. Yeah.
I have a stupid hypothetical physics question.
Go for it.
It's really stupid though.
I'll be the judge of that. Go for it.
So, have you seen X-Men before? A Marvel movie?
I know
The
X-Men.
guy can shrink really small?
Oh, what's his name? Dr. Atom? Mr. Atom?
No.
No. Ant-Man?
Ant-Man.
Yeah, okay, yeah.
So, considering the smallest length we ever could found is Planck's length,
Yeah, it is, correct.
is it possible if a man of his size like shrink to that size, would it be possible for the man to be so dense that a black hole creates?
Oh, that's interesting actually, yeah, because he's shrunken down. I mean, it is possible, but not for the man. To put it into sort of a scale, if you take the whole Earth, it would have to shrink down to something, which is only about, I don't know, like a centimeter in size before you would have that happening. So, for the man, which is obviously much smaller than the Earth, it would have to be really, really small, but The other thing is, if he shrunk as small as you said, he would, because you can't really have things that small. I mean, they lose their definition, if that makes sense. Because the way I think about it is, Planck's length is a bit like a screen resolution. Do you know what I mean? So like you obviously know that your screen is made up of lots of little pixels. So could you have an image which is smaller than 1 pixel? No, because 1 pixel is the smallest. So you can have like 1 pixel which could be coloured in black. But if that's the smallest, you couldn't have something smaller than that as an image. Does that make sense? Or yeah. So I don't think he has to worry about that. I don't think it'd be a concern.
In the movie, he started shrinking.
Yeah.
His device went wrong. He went so small that was like, what was quark?
Okay. It's getting a bit too far-fetched then, yes.
It got confusing to me because at that point he would be dead because he can't get in oxygen molecules. So
yes.
and then that part got confusing to me. So I wanted someone to ask, but there was no one to ask.
Yeah. Yeah, you see, obviously for science fiction it's not accurate, but sometimes they go a little bit too far. I think they made him too small at that stage. I haven't seen the movie. Is it good? Not so good? 3 out of 5 stars?
Yeah.
Yeah, okay. Average then. Anyways, I'm not a big fan of Marvel. I prefer DC.
Aww.
I know, it's a shame. It's a shame. Yeah. And I can tell you're a Batman. Right?
She wore a Captain America shirt yesterday.
No, I did notice that, and I felt it would be inappropriate for me to say something now. Yeah, we won't judge. We won't judge. Yes, okay, yeah. You're not making any statement. No. But seriously, am I right in Batman v Superman?
Yeah.
Your team Batman? Yeah. What do you think of Wonder Woman movie? You haven't watched it because you haven't gotten around to it. I thought it was good. I'm looking forward to Justice League.
Oh yeah, I'm looking forward.
When is it out?
Hmm?
Is it next year?
It's
Next year. Should be good.
What should be
Hoping it should be good. Huh?
What should be there in the class?
PirateBay.org.
Torrent.
Yeah. And I actually thought Batman v Superman was okay. It was okay.
Yeah,
It got a lot of hate.
Yeah, I got a lot of hate because of like
Yeah.
the ending part.
Yeah, but I thought it was okay. It wasn't like the way people were talking about it. I thought it was going to be like a disaster. It was all right. Yeah, we'll finish there. So for next week, it would be very helpful if you can write down which questions we'll do so we can do them. Okay? Yeah. Okay. What class have you got now?
Exam prep, but it's not.
Are you finished for the day?
No. We still have afternoon out here.
No, we have group tutorial.